Welcome, software engineers and command line enthusiasts. I am your expert technical instructor. Today, we are focusing on a game-changing tool for your development workflow within the GH-300 certification, defining the GitHub Copilot command line interface, and exploring exactly how it benefits developers. Let's elevate your terminal experience. Welcome to this crucial training module covering the GitHub Copilot command line interface, a highly testable topic on the GH-300 exam. While developers spend a massive portion of their daily workflow inside their integrated development environment, the terminal remains the ultimate control center for executing builds, deploying infrastructure, and managing version control. However, even the most proficient engineers frequently struggle to remember the precise syntax for complex shell commands or obscure Git flags, forcing them to constantly context switch into web browsers to read manual pages. The GitHub Copilot CLI solves this exact problem by bringing powerful, terminal-native agentic artificial intelligence directly to your command line. So what exactly is the Copilot CLI? It is a highly extensible, interactive AI agent that operates entirely within your terminal, utilizing your existing GitHub authentication. Unlike simple autocomplete scripts, Copilot CLI functions as an autonomous coding partner, capable of reading your local file system, suggesting highly optimized shell commands based on natural language descriptions, and executing complex workflows on your behalf. Whether you need to investigate a failing build, scaffold an entirely new project, or navigate a massive, unfamiliar directory structure, the CLI drastically reduces guesswork. It operates independently from the standard GitHub CLI tool, although they complement each other beautifully. By the end of this module, you will understand how to invoke this tool interactively, automate repetitive tasks programmatically, utilize custom agents, and ensure your terminal environment remains highly secure while maximizing your daily engineering velocity. This simple execution command initializes the GitHub Copilot CLI in interactive mode. Upon the very first launch in a new directory, Copilot will immediately ask you to explicitly confirm whether you trust the files in the current folder. This is a vital security feature, as the agent may need to read, modify, or execute files during its session, establishing a secure boundary. Always ensure you are in a trusted workspace before accepting. This flowchart maps the basic initialization sequence of the CLI. The developer types the invocation command in the terminal. The system immediately verifies if the active directory is trusted. A fundamental concept you must master for the GH-300 certification is how to invoke the GitHub Copilot CLI using either interactive or programmatic execution modes. When you type the Copilot command without any arguments, you launch an interactive session. This provides a persistent, chat-like interface directly within your terminal window. The interactive mode is incredibly powerful for exploratory tasks, debugging deep architectural issues, or planning multi-step refactoring operations, where you want an ongoing, conversational dialogue with the underlying large language model. However, for DevOps engineers focused on automation, the programmatic mode is equally essential. By utilizing the -p or -- prompt flag, you can pass a natural language request directly to the Copilot CLI in a single, one-shot command execution. This allows you to effortlessly embed AI capabilities into your existing shell scripts, continuous integration, and continuous deployment pipelines, or scheduled cron jobs. For instance, you could write a bash script that automatically pipes a failing build log into Copilot CLI, asking it to diagnose the error and output a suggested fix. When utilizing the programmatic mode, it is highly recommended to use the --s or silent flag. The silent flag forcefully suppresses all extraneous session metadata and formatting, ensuring that the CLI outputs clean, parsable text that can be seamlessly captured by variables or passed to other command line utilities. Understanding when to use persistent interactive sessions versus programmatic one-shot executions is critical for optimizing your daily workflow and passing the exam. This shell script snippet perfectly demonstrates programmatic execution. We use the Copilot binary with the --p flag to ask for a brief description of a specific file. Crucially, the -s flag is applied to return only the raw text response, while standard error is redirected to dev null. This allows the bash script to capture the AI's output securely into a shell variable. This visual breaks down the two primary execution pathways. Executing without flags enters an interactive chat session ideal for exploratory debugging. Conversely, passing the -p flag triggers programmatic execution. By appending the silent extraction flag, the raw output is seamlessly funneled into CI/CD pipelines and automated bash scripts. Within an interactive GitHub Copilot CLI session, you control the behavior of the AI agent primarily through the use of /commands. While you can always type natural language queries to ask general questions, /commands provide explicit, structured directives that govern the session settings and configuration. It is an exam-critical fact that /commands cannot be replaced by natural language prompts. They are the exclusive mechanism for session control. For example, if you encounter an obscure shell script left by a former employee, You can use the /explain/command followed by the command string to receive a detailed breakdown of exactly what it does. Conversely, if you know what you want to achieve but lack the syntax, the /suggest command allows you to describe a task in natural language, prompting Copilot to generate the exact shell command required. If the initial suggestion isn't quite right, you use the /revise command to refine it. Beyond command generation, /commands dictate the overarching environment. You use /model to dynamically switch between underlying AI models, such as moving to Claude 3.5 Sonnet for deep reasoning tasks. You can use /theme to adjust the terminal appearance, /skills to manage specialized capabilities, and /MCP to configure model context protocol servers. Furthermore, utilizing the /feedback command allows developers to submit direct bug reports or feature requests to GitHub regarding the CLI experience. Mastering these distinct /commands empowers developers to rapidly iterate on complex terminal operations without ever needing to break their focus or search through external documentation websites. Here we see a developer utilizing /commands to progressively refine a terminal operation. First, the developer uses /suggest to find all large files modified recently. The AI generates a find command. Realizing an omission, the developer immediately issues a /revise command to add an exclusion for the .git directory. The AI seamlessly updates the syntax in real time. This diagram illustrates the role of the /command router within the CLI. Based on the user's input, the router diverts the request. /explain analyzes scripts. /suggest and revise iteratively generate commands. /model swaps the LLM. And /MCP manages tools. This structured routing guarantees precise execution directly in the terminal. Now let us explore the tangible, real-world developer benefits of integrating the GitHub Copilot CLI into your daily operations. The core advantage is the dramatic reduction of cognitive load and context switching. Because Copilot operates directly where your code lives, it excels at complex Git workflows. You can simply ask the CLI to summarize what changes went into a specific release version, resolve complicated merge conflicts in your package configuration files, or even automatically generate a pull request with a detailed description based on your current branch history. Beyond version control, the CLI serves as an unparalleled debugging assistant. If an API endpoint is throwing intermittent 500 errors, you can instruct Copilot to actively search your codebase and server logs to identify the root cause. For massive structural updates, developers can utilize the plan mode by pressing Shift+Tab, asking Copilot to migrate legacy class components to modern functional hooks. Copilot will output a step-by-step strategy. Once you approve the plan, you can trigger autopilot mode. In autopilot mode, the agent works entirely autonomously, modifying files, running tests, and iterating through failures until the objective is fully complete. This agentic capability transforms the terminal from a static execution environment into a dynamic, intelligent workspace, where you delegate tedious architectural migrations to the AI, freeing your engineering team to focus exclusively on high-value business logic and product innovation. This interactive prompt showcases the incredible power of the CLI's advanced delegation capabilities. Instead of manually reviewing thousands of lines of code, the developer explicitly instructs Copilot to utilize a specific model, Opus 4.5, to review uncommitted changes against the main branch, instructing it to prioritize security vulnerabilities and bugs before merging. This effectively shifts left your security posture, catching severe architectural flaws directly in the terminal before a pull request is ever opened. This flowchart demystifies the autonomous workflow. A complex request triggers plan mode, yielding a strategy. Following human approval, autopilot mode initiates. The agent autonomously edits files and runs unit tests. If tests fail, it enters a self-correction loop, iteratively refining the code until all tests pass and the feature is marked complete. With immense autonomous power comes the absolute necessity for strict security guardrails. Copilot CLI is a terminal-based agent that can read and write files, execute shell scripts, and make network requests. To prevent accidental data destruction or malicious prompt injection attacks, the CLI employs a rigid, deny-by-default permission model. While safe, read-only operations like searching directories are permitted automatically, any tool that modifies your system requires your explicit human approval before execution. When Copilot attempts to run a destructive command, it will halt and prompt you to allow it once, allow it for the entire session, or deny it entirely. For automation workflows where human intervention is impossible, you must proactively manage these permissions using command line flags. By passing the --allow tool argument, you can pre-approve specific operations. For instance, granting shell, git smiley face, permits all git commands, while granting write allows file modifications. It is a fundamental security best practice to always adhere to the principle of least privilege, never using the overly permissive --allow all flag outside of isolated sandbox environments. Furthermore, administrators can enforce organizational policies by implementing pre-tool use hooks. These custom JSON-configured scripts evaluate requested tool calls in real time, allowing security teams to programmatically block high-risk bash commands or prevent modifications to protected infrastructure directories, guaranteeing that AI acceleration never compromises enterprise compliance. This programmatic execution string demonstrates how to securely manage tool permissions in automated pipelines. We explicitly use the allow tool flags to grant Copilot the exact minimum permissions required to run Git commands and write to the file system. The no ask user flag is absolutely critical here. It prevents the CLI from endlessly hanging while waiting for human input in a headless CI/CD environment. This visual maps the rigorous defense in-depth security model. When the AI generates a command, a pre-tool use hook evaluates the payload. If it violates policy, it is blocked. If not, the system checks for pre-approval. If it lacks a pre-approved flag, it prompts the human operator for manual approval, ensuring zero unvetted modifications occur. To conclude our comprehensive overview of the GitHub Copilot CLI, we must address advanced customization techniques that are heavily tested on the GH-300 certification exam. To maximize the agent's effectiveness, you must configure custom instructions. By creating a copilot-instructions.md file within your repositories.github directory, you persistently enforce your team's specific build commands, coding styles, and architectural decisions across every CLI session. You can also significantly extend the CLI's capabilities by integrating Model Context Protocol, or MCP servers. By adding MCP servers to your configuration, you grant the CLI secure access to query internal databases, read external issue tracking systems, or interact directly with your deployment pipelines. Furthermore, the CLI continuously records your session history locally. By leveraging the experimental/chronicle/command, you can command Copilot to automatically generate highly accurate daily stand-up reports based on your actual terminal activity, or ask it to provide personalized productivity tips by analyzing your prompt patterns. By masterfully combining programmatic execution, strict security guardrails, custom instructions, and MCP extensions, you elevate the GitHub Copilot CLI from a simple terminal assistant into a deeply integrated, highly compliant, enterprise-grade AI partner. Thank you for joining this deep dive. To fully validate your skills and guarantee your success on the GH-300 Mastery Exam, visit quicktechie.com today for comprehensive practice tests and advanced interactive labs. This interactive prompt sequence highlights the experimental Chronicle feature, a massive productivity booster. By executing/Chronicle standup, the CLI scans its locally stored SQLite session database to summarize the exact branches you worked on and the pull requests you referenced over the last 24 hours. The /Chronicle improve command actively analyzes your history to suggest automated updates to your custom instructions file.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material. So this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this and all the practice papers are available here. Today we have 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.